Welcome to Problem Set Week 9. We're living it up this week using my sticky notes because I did this at work instead of at home during my lunch break. So I don't have the whole written out setup to it, but I have the answers. So starting with number 1, the question I believe asks you about a family of rabbits that starts with 1 and they reproduce a pair every new month. But that pair can't reproduce themselves for 2 months after they're born. Sorry if that made it complicated. It was just a long, drawn-out way of describing the Fibonacci sequence. So you start with 1 rabbit, and then you have 1 rabbit, and then those rabbits reproduce, and now you have 2 rabbits, and now add the 1 back here, or the same 1 rabbit makes another 1 rabbit, so now you're at 3 rabbits. And then boom, lo and behold, this one can make another one now because it's been the 2 months. So now there's 2 more rabbits being added, and then and so forth. Fibonacci sequence. Pretty easy. It's fn equals fn minus 1 plus fn minus 2 for n greater than 1. So if you want this one, you gotta add these 2. If you want this one, you gotta add these 2, and so forth. For number 2, this is basically what the equation was. There was a D instead of 2 million and an R instead of 0.01 and something else instead of 20, but I just filled them in as the question asked. I used the integral test method, I believe, where you separate it into kind of a bunch of little squares. That's how they explain it in the video. So first I found the point on my first square, which was going to be just solving that for 1. And anything to the negative 1 is basically like dividing by that exponent. So that's still technically to the 1. It's 2 million divided by 1.04 to the 1, plus the integral from 1 to 20 to make your rough estimate. I converted the I to an X just because that's normally what we use for this type of math. After solving for this, you find that this is the answer from 1 to 20. You plug, and then you add this number. This is the 2 million divided by 1.04. And then after solving this part from 1 to 20, you will get 12.879. You multiply that by your 2 million, because 2 million is a constant. You pulled it out earlier. That's why I have the star multiply. I forgot to write the 2 million there. Sorry, please don't deduct points. And then that equals this long number that I underlined for the answer to part A. Then there's a comma, and then I'm solving for the 1 to infinity. If you take this equation to the infinity, it's 1 over infinity, which is 0. So 0 minus, solve for the 1, 24.51, makes that a positive, times your 2 million plus your number you found earlier. So after an infinite amount of time, that's how much money you will have. Not an infinite amount of money. For number 3, it was pretty simple. You just gave 2 equations and told us to tell if it's divergent or convergent. Convergent. So then I wrote them out here. Both were a type of p-series. A p-series will be convergent for if p is greater than or equal to 1. It looks like I forgot to write a 1 there. And divergent if p is less than or equal to 1. So I didn't write out the series symbols for these because they're not relevant for it. But I wrote this out. That behaves similarly to that. And since that is equal to 1, it is divergent because this isn't actually supposed to be greater than or equal to. It's only supposed to be greater than. And I miswrote. But my answers are right. And then b, n to the negative 3, like I said earlier, it basically puts the exponent in the denominator, which is 1 over n to the 3rd, and that is convergent. And I forgot the n every single time I wrote convergent. So there we go.